Okay, so I really think that the paper does a great job of bringing out the tension between the position that Colombo and Series occupied in their early paper and the one that he has now taken in collaboration with Hartman. However, I recently became aware of their upcoming paper, which is about dealing with uncertainty. I want to ask you about this. So it's regarding the first challenge about whether Bayesian models can actually constrain the space of all possible models in the way that you discussed in connection to the sensory-motor integration case. So in this preprint of their paper, they actually argue that Bayesian statistics are not the only way of dealing with uncertainties, right? So they point out to several other ways of dealing with uncertainty, formal ways of dealing with uncertainty, such as the Dempster-Schaefer calculus and several other methods. And I was just wondering whether, in the case of sensory-motor integration, the fact that signal streams are weighed may not be enough to circumscribe the search space to just Bayesian models in that case. It is possible that there will be other formal descriptions which deal with uncertainty and also weigh signal streams in a similar way. I was wondering how you would deal with that. That's the first thing. And I see one possible solution here, which would be to claim that these different formal descriptions would then make different predictions about the overall behavior of the system, for example. So this is a suggestion that's made by Judea Pearl in the introduction to his 88 book. But I was wondering what you would say about that.
Okay, can you hear me? Yeah.
Yeah.
Okay. Yeah, that's a great question. I've not read that paper, so I don't know. I don't know the specifics. But I guess part of what we're trying to do is make what we think is a pretty minimal kind of claim about the degree to which, say, like a purely behaviorally supported Bayesian model can actually constrain the space, right? I don't think it actually. I don't think we're not committed to the idea that it heavily constrains the space of possible mechanisms. But I think it's reasonable to think that it does provide some constraints, and so even a purely behavioral model. Just in terms of thinking about thinking about the fetch model, for example, there's going to have to be some way in which uncertainty is tracked in the system. So it doesn't have. So again, I talked about two different models for how reliability dependent sensitivity could be implemented, right? One is a population level, the PPC model, suggesting that you get it for free because of noisy responses of individual neurons at the population level. The fetch neural model shows how on a trial by trial basis, there are neurons that are sort of changing their weighting as a function of reliability of the information, the visual and the vestibular information. So, but at a minimum, what you have is evidence that rules out all sort of a vast number of mechanisms that are not sensitive to uncertainty, which, again, I think is, I don't think it's a major concession for like someone like Colombo and Hartman to make, but it does seem to me that that's happening, right? So that's that kind of information about the activities of whatever. We don't actually know the sort of activities that aren't associated with components. We don't know what the components might underwrite that. It could be an entire population, it could be individual neurons, but the behavioral evidence alone, just on the basis of the psychophysical data, the fact that you see these shifts in the psychometric curves in this heading direction task, that's where the reliability of the visual and vestibular information is the reliability of visual information is manipulated, seems to indicate that there's got to be something in the system that is tracking that in order for the behavior to reflect it. And so I think it doesn't matter whether it's so there could very well be, and I think there are examples of, like this sort of like ways of representing uncertainty in terms of sampling, for example. And I think that that's another way to do it. So what I'm not saying is that you will always, this heuristic will always, I mean, again, I think that the idea is that the discovery heuristic is defeasible. You're very probably going to frequently find situations where there is no mapping between the Bayesian kind of behavior and the Bayesian mechanism. But nonetheless, the fact that the behavior reflects something like sensitivity to uncertainty and is well accommodated by a Bayesian model already provides some constraints on the space of possible mechanisms, because there's going to have to be some things in the system that are tracking uncertainty, might not be representing uncertainty in terms of probability distributions. There are other ways to do it, but nonetheless, it seems to me that there's still an important sense in which there are constraints that are applied. Does that address your question?
Yeah, I think so. So what I was kind of trying to point to is that the Bayesian models may constrain the space of possible mechanisms the way you described it, but that doesn't mean that the underlying mechanism must be Bayesian, right? It just shows us that it has to deal with uncertainty or something like that. Do we have time for one more question? Yeah. So the second question I wanted to ask you is, and it's somewhat related, and it relates also to the second challenge that you present for them. And I'm just worried that clamping down the degrees of freedom of Bayesian models through background assumptions, as you proposed, such as the assumptions about the appropriate level at which the neural model should be specified, and the localization assumptions about where in the system the underlying mechanism might be located, I'm worried that this will be not enough to disambiguate between competing Bayesian models. So I think that we already have some cases where we already agreed on the background assumptions of the location and the level of description. Level of the mechanism. And the problem is that even though we are holding them fixed, there is still more than one formal description, Bayesian description, which will explain what's happening or describes what's happening on that level. So there's a recent paper by Lawrence Aitchison and Matej Langiel called With or Without You. It's about Bayesian probable inference and predictive coding, I think. And then they basically make this claim that focusing on single neurons, I think, where they show that there are different ways to implement Bayesian inference in a single neuron, and that there isn't really a good way of disambiguating between these different possibilities. And my question here would be whether in that case the competing Bayesian models are then confined to being just somehow plausibly models, for example, or what would be your take on that specific case?
Yeah, no, I mean, those. Maybe you can afterwards send me those
Sure.
references. It sounds really interesting. It's a great question. Yeah, I guess I sort of think. I think that like something like the fetch model is not the end of the story, right? I mean, I think this is getting at your worry. To me, we're not claiming that that allows us to sort of that in conjunction with, say, I like that term because we're clamping down on the the location assumption and the
level.
Sorry. Localization. Yeah, right. The location and the level assumptions. I don't think that the data that supports the fetch et al. Neural model in conjunction with sort of these clamped down assumptions about level and location, give us sort of a single mechanism. And I think that, you know, part of what I think is right about the ways in which philosophers have kind of thought about constraints, and, you know, thinking about like Carl's work and other people have built on some of Carl's work on constraints and mechanism discovery, is that there's lots of really incredibly sort of important information that we still lack, right? I mean, the neural firing rates of these, we don't know that these things are even causally involved. These are sort of neural correlates of behavior. So there's still a disconnect. You know, the temporal properties of the weighting gives us some indication that it's probably not going to be synaptic weight. So it allows us to sort of rule. So I think it does allow us to rule some candidate mechanisms out, but you know, it doesn't rule in something like normalization. It's just that it's, you know, the timing is actually, the time scale of normalization computations is sort of, you know, close enough that that could be possible. But, you know, we'd like a lot more evidence about this. We'd like a real sort of detailed, you know, a model that explains how those different vestibular neural weights are actually implemented, which we currently lack. And it seems to me that there could be lots of different ways that happens, right? I mean, I think that's, to kind of speak to your point, I think that not committed to just adding in constraints, adding in these assumptions, fixing the background assumptions about level and localization will allow us to sort of like isolate that single mechanism for multisensory integration. It's just that, you know, that's just another free parameter in this discussion that prevents us from kind of like getting to the bottom, getting to that single mechanism.
Yeah, I mean, so good. I'm also sympathetic to a lot of the stuff in this paper. So I guess, but I wanted to, I don't know, ask Press a little bit about whether there might be even, whether the situation might be even looser. So some of this is pressing on, you know, this question of, insofar as you've got constraints, what kind they are, whether they're just behavioral, and how much you constrain things down. And so, yeah, one thing I've got in mind and that I've used to write on was about really idealized models. But there's a lot of interesting work on idealized models and how useful they are. So one of my favorite examples of this, you know, there are a lot of models of traffic and how traffic forms traffic jams. And one of the really successful ones for a long time, and I think still gets used, is, I'm not quite sure if I say his name right, but Ilya Prigogine, the complex systems guy. And so what you do is you start by modeling traffic as an incompressible fluid with certain parameters and a certain viscosity. You use flowing through a tube, you use the Boltzmann equation, and depending on how you set this up, it works really well and predicts, you know, given how many lanes, whether you're going to get traffic jams. And there are also, you know, there are other models that are harder to use, but give you kind of the same thing, that treat cars as cars that are more agent-based. Now, the interesting thing about the Prigogine model, right, is that in some sense it's giving you information about the mechanism, but by, like, traffic isn't a fluid. Like, it's this obviously false, and it, you know, treats it as a continuous phenomenon, whereas cars obviously come in chunks and so on. So, I mean, I feel like there's two kind of, well, maybe like a problem here, something like a problem, I'm not sure. And then also sort of another perspective more from philosophy of biology. So, you know, the problem seems to be that insofar as there are constraints, we're now getting an extremely broad set of constraints where it's like, you know, behaviorally consistent with this, even if the mechanism resembles it, you know, mechanism proposed resembles it in almost no interesting way. And there's an old paper, I don't know if you know, Levin's, this is like 1966, I think, The Strategy of Model Building in Population Biology, where he says, you know, one way to treat these things is to take a bunch of models that you know to be false to the world and look what's true, as it were, at the intersection of all of them. So you go through and you find, he's got this great line, something like, our truth is found at the intersection of competing lies. And I sometimes have this feeling about some of the Bayesian things, Bayesian models that get presented. They have this extremely abstract and obviously simplified picture. And what you're doing is you're getting something out of it, but until you start going through this process of comparing them to other models and seeing, other experimental data and seeing what holds and what doesn't, it's kind of, to me, this is the way to put it, even model by model, it's not clear to me that you get constraints, as opposed to getting a bunch of models and kind of seeing what they all agree on or how they, do that thing. So some of this is just maybe an invitation to expand out even more on how you see the constraining process working.
Yeah.
And what what the possibility is that some of these are actually like more like the Prigogine like continuous flow model of traffic than like the pistons.
Yeah, yeah. Oh, so yeah, really, really interesting issues that you raised. Thanks, Colin. Yeah, I mean, maybe speaking to that, I mean, I do think that this sort of relates to the response I gave to Chris about, I mean, I do think there's something right about this idea that the discovery heuristic that a behaviorally confirmed Bayesian model provides is a sort of highly defeasible one, and that we should be open to the possibility that the underlying mechanism is not at all, does not at all resemble the structure of the behavior. And I mean, I think even a simple example, like, there's almost no good reason to think that, the probability distributions could be or are represented separately or as probability distributions, right? I mean, we don't think that. We don't think that. So I think we have to be kind of, so that seems to me just a sort of like, that's got to be your starting point from this, is like that the discovery, the way in which Bayesian models and Bayesian models that are supported by behavioral evidence provide constraints in the space of possible mechanisms is as a heuristic, right? I mean, I think really sort of like lean into the term heuristic there. It's like, it's defeasible, and it doesn't provide us with a straight route to the underlying mechanism. So I think that's. So I think that's not. I think the example you gave is a nice one, but I think that there might be ways to kind of tease out the ways in which that idealized model might yet still provide some constraints on the space of possible mechanisms. But again, I think that's. But it's not obvious. It's not very obvious how that would go. But then I think sort of to your second point about the Levins, I mean, the Levins code is great, and I hadn't really ever thought about this stuff in the context of sort of thinking about Levin's work on idealized models. But I mean, I think that one thing that your query raised in my mind is this idea that, part of what I completely agree with you that sort of like thinking about the sort of evidential support for these models kind of in a vacuum is sort of the wrong way to do it. And it's sort of like, if we think about it in kind of like model by model, we might be sort of led astray. And I think that, the background picture that we're working with, this kind of picture of a kind of jigsaw or crossword puzzle model of constraint is, I think, the byproduct is sort of in the background, or sort of reflects that assumption that you can kind of do in this atomistic way, like, here's this model, here's evidence for it, here's this other model, evidence for it, and you kind of throw it all in, and like at the end, each one, and to sort of lean on Carl here, but I mean, I think, the chapter on integrating, his sort of view about the sort of mosaic unity of neuroscience is sort of this picture where, if you're thinking about something like LTP or like, spatial memory phenomena, you sort of like throw in different findings from different fields, different models, and each time you throw in more evidence, you're getting, you're pruning the space further and further and further. And I guess part of what I think this, even thinking about just the models that we were describing in this paper, is it's way messier and complicated in ways that I think Levins would probably, it would be obvious to Levins. It's sort of like they all involve different sort of false, idealizing assumptions, and you kind of have to think about how they all fit together. And when you start thinking about how they all fit together, then there's going to be inconsistencies that have to be resolved. And what happens when you find out something about one model being inconsistent with another? does it mean that one model is automatically thrown out? Not necessarily. One thing you could do is sort of like unclamp that assumption about the level so that it sort of can be saved. Another thing it might do is sort of like raise sort of real questions about, look, maybe there's sort of some space of possible mechanisms for this that involve, that are sort of, haven't really been thought about before, right? Other dimensions that get opened up, other areas of the space that we previously went unacknowledged. And so I think, I don't know how that story goes, but it seems to me that there's got to be something, there seems to be something overly simplistic about this view that as you add in additional constraints, you monotonically decrease the size of the space of possible mechanisms, and that what that more nuanced picture looks like, I don't really know.
Yeah. Could I say one thing, which I think is meant to be helpful here, but I think, there's this picture, and I wonder, without being able to flesh this out on the fly, I mean, I like putting it in terms of non-monotonic decrease. And so I feel like there's this sort of, what feels like a conflation, not a conflation, but like there's a very basic point, if you think of like in terms of Lewisian propositions, that like learning any proposition reduces the space of possible worlds you might be in. So like there's some sense in which getting new information already lays things down. But what that doesn't mean is that like we have a great grasp of what the possibilities might be. So in many cases, it's more like, the detective who looks at someone and says, well, he wasn't shot, but there's a huge number of possibilities, and so in some technical sense, that reduces the space of possibilities. But like, there are a whole bunch of possibilities, including ones that the detective and the reader haven't thought of. Like it turns out he was strangled by an orangutan. Who would have thought? So, and I feel like so many cases, what you've got, and I think you're hitting on this, is that's quite right. Like we are getting some kind of information, but it's maybe not something more complicated can happen to open up this space of possibilities to us, even if this technical point is kind of true. So anyway, yeah.
Yeah, no, I agree.
First of all, my overall idea about Bayesian models in the brain is much in line with your, and so also not far from that of Marco Colombo. In particular, I greatly appreciated your clear distinction between unification and explanation. I was already familiar with your argument when you used it discussing canonical computational models in your recent book, and I also made use of your arguments. There are few elements that left me skeptical about the virtues of Bayesian models, in addition to your considerations, and I would like to tell you and listen to your opinion. But concerning your presentation, I have just one comment, but that is much in overlap with the previous one. It's again on your second reason to challenge the idea of Colombo to make use of Bayesian models as constraints. So I say it very quickly because in part you already responded. My concern is that your point is these constraints cannot narrow down to one single model. You provided the example of the two different models, probabilistic population code and fetch model, which are both constrained by Bayesian model, but are inconsistent with each other. My question is, it is a requirement for a constraint to really narrow down to just one single? In general, not. In the book of Krever too, a constraint means just reducing the search space. You also address the point that this constraint does not work in a monotonically way, like, for example, constraints for data evidence. However, evidences can add, and so it's important to see if they work in a monotonical way. But the constraints given by Bayesian framework is just one, so we don't have the problem of adding more and more Bayesian constraints. It's just one. So I cannot grasp the cogency of your challenge. I guess that if a constraints work in reducing to a few mechanistic plausible models, it may do a good job. I'm not defending the power of Bayesian model as constraints. Just I can grasp the point of your argument.
Okay.
Now, my perplexity about the Bayesian brain is that almost in all introduction in the recent literature that praise for Bayesian model is that this is the single basis of probabilistic approach in neuroscience, in cognitive science, if not in science at all. This is maybe the case just in cognitive science, because the simplicity of the Bayesian formulation it's really very useful for simple scheme of behavioral models. But it's not the case in general. In current mathematical statistics, Bayes is today almost abandoned, since the basic treatment of probability is on other fundamental basis, on set theoretical foundation, based on the early formulation of Kolmogorov, then mixed with theory of integrals, information theory, theories of random processes, and so on. Bayes is almost disappeared. Even in the statistical analysis of neuroscientific data, where certainly Bayes is still an option, but it's just a partial option. In decoding of spikes or voxel in fMRI, there are many other approaches that gain now space and are much more effective. First of all methods belonging to machine learning. So I have the impression that the premise of unification not only implies explanation, but also is not so strong as often described.
Okay. Thanks, Alessio. Really interesting comments. I'll try to address a couple, and then if I miss something, maybe just come back and explain to me what I've missed. I think kind of related to that, maybe I'll just do the last point first. I mean, I think that it's absolutely true that there's an important sense in which the Bayesian brain, the Bayesian coding hypothesis is, and all these sort of variations on probabilistic approaches, kind of everything that falls under sort of probabilistic approaches to brain function, is, kind of it's a very popular way of thinking about what the brain does, but sort of that, I don't think that's an indictment of it. I mean, I think the fact that there is considerable behavioral and neural evidence that at least some neural systems do something like probabilistic inference. So I think we're often struggling for kind of metaphors to capture the way things work, and before we really have detailed models, we sometimes lean on sort of these very abstract kind of models. So computational model, digital computer, and so I think you're absolutely right to say that it's not the only game in town. There's other sort of there's other ways of thinking about information processing in the brain that is not Bayesian, and I think that's all. Everything I've said today is sort of compatible with probabilistic or Bayesian estimation being true of only perhaps some neural systems. I guess one question sort of to kind of make it very concrete is like, if we kind of focused on the neural data from Fetch et al., it's like, what would the alternative model look like that didn't have reliability dependent weighting in a way it was kind of consistent with Bayesian integration. I think that's the kind of level at which the discussion gets really interesting. What are these alternative models? And I think it is, you're perhaps pointing to a kind of important limitation of some of this work, that often multiple different models are not sort of evaluated. And even if you go back to the first example that I described, the Korting and Wolpert study, that sort of behavioral evidence confirmed, behaviorally confirmed Bayesian model. The two models that they pitted the Bayesian estimation model against were really quite unrealistic and not real competitors. So I think it would be a really interesting kind of development in contemporary cognitive science to sort of see whether some of these more sophisticated frameworks that you're talking about could potentially deliver model predictions that better fit the data that we've got. And I think everything I said today is sort of compatible with that that kind of thing being true. And then just to sort of maybe wrap up by saying about the kind of this sort of picture of evidence kind of moving us to a place where we sort of get to one single mechanism, so evidence accumulating to sort of increasingly shrink the space of possible mechanisms. I mean, I do think that that's part of what's in the background of views like Carl's. We're looking for basically a mechanistic explanation for a given phenomena. And I think then there's a sort of question about like, well, what is the phenomena that we're trying to explain? But I think, if we fix the sort of explanandum phenomena, I think there is a sort of important sense in which we're looking for the mechanism that sort of supports or is responsible for producing that phenomena. And I think if we give up on that, then it's sort of multiple phenomena. Multiple mechanisms that might do it. I mean, that could well be true, but I think we're thinking about we're thinking about a specific kind of phenomena, like say multisensory integration in MSTD neurons, right? The fact that they're doing this reliability dependent weighting. I think the question is sort of what's the mechanism that underwrites their reliability dependent weighting, and I think the answer. There is a single answer. I think that's a reasonable assumption to have. That's a single answer. The story could be that it's this sort of dynamically changing mechanism that isn't static over time, but it's still a single mechanism. So I think that I don't see how we can kind of jettison that assumption that what we're doing here is trying to add in different sources of evidence to ultimately constrain the space of possible mechanisms to down to one. And again, that's sort of like a philosophical framework for thinking about how these things work. It's not it's not necessarily, it's not intended, I don't think, to be descriptive of like how science actually works, because we might still be committed to the idea that we're never going to get to that place, or, you know, it's possible at least that we never get to that place where we've got single mechanisms. We know the mechanism responsible for a given phenomenon. I'll stop there.
Thanks, Dave, for the great talk. I have a question about the meaning of constraints as well. And so you refer to Carl's work in explicating sort of the notion of constraints that we're operating with. And I was wondering how that compares to this work on constraints, for instance, by Sarah Green, but also others that look at these sort of more general principles to constrain the space of possible mechanisms. And so she calls it constraint-based generality. And she describes it sort of, so there the example, for instance, would be a bistable toggle switch, right? So that delineates also like a class of mechanisms that sort of implement that type of component, although that could be, of course, multiply realized, but it also formulates like what it enables these kinds of mechanisms to do, because like a mechanism with a bistable toggle switch would be able to you know, ensure that two mutually exclusive patterns, for instance, like gene expression, remain stable across different initial conditions. So the point I'm getting at is that I think while it's true to think of constraints as like restricting, I think the flip side of that is the enabling part, so that we think about that they provide some sort of positive formulation of what the system can do, like given that it respects those constraints. And so by like formulating these sort of enabling conditions, it allows us sort of to say also something positive about the class of systems that are so constrained. And so it seems to me that in sort of Carl's formulation, that bit, that enabling bit, is sort of missing, and therefore it seems like, well, if you have a constraint, you might have that situation where you, like that the situation that Colin adhered to with the detective example, where you can't say anything positive. And it might be interesting to see, so for instance, in your cases, what would be, you know, from saying that it has to, the models rule out mechanisms that can't, what was it, deal with unreliability, something like that.
Like reliability, sensitivity to like unreliability or uncertainty. Yeah.
Right. So it would be interesting to think about what that so the mechanisms that you rule in, what can we say, what does that enable the system to do, right? Not just saying, well, it somehow produces the phenomenon, but something more specific. So in the ways in which it does so, or in ways in which it does contribute to the phenomenon. And like, once we go there, I think you may get a bit richer picture of constraints than just the restricting bits. Does that make sense?
Okay. Yeah, I think so. Yeah, that's an interesting point. Thanks for that. I don't know Green's work on this, so I should look at it. So thanks for that. I guess one thing that I was thinking when you were talking is, it is certainly true that I think what, you know, in Carl's book and the way I was sort of characterizing constraint is sort of this. And I think Colombo and Hartman also sort of thinking about constraints as a way to kind of discover a particular mechanism. I think it's true that you can kind of step back a little bit and think about what other work does this what other work do these constraints do? What other scientific work do they do? And I think it could very, you know, it seems like it must be true that one other thing they do is generate new predictions about other domains. So, for example, you know, if you add in some piece of evidence that sort of allows you to sort of monotonically decrease the space of possible mechanisms for a given phenomena. It could very well be that that allows you to make predictions about other phenomena. And I don't think anything, I mean, I guess that's just sort of, to me, that seems like an incredibly interesting issue. That's I think just a different kind of question about how different pieces of evidence added together, what benefits do we derive from them, scientific, in terms of science? And it seems to me that's a really interesting possibility, is that doesn't just adding in new pieces of evidence doesn't necessarily help us to discover the mechanism for the particular phenomena that we're interested in understanding, but might also generate really interesting predictions about other phenomena. And maybe that's what you were getting at with that bistable toggle switch example, which is sort of, you kind of get to the point where you've sort of characterized the system where you know there's some kind of like bistable toggle switch mechanism. And you might say, hang on a second, that seems to really sort of capture what's going on in this system, and it allows us to sort of port that in from all that work over to this very different domain, like maybe in genetics or something.
Right.
Is that?
Yeah, I mean, part of it is this sort of modular subassembly idea, right? That like you draw on like known components or modules from previous work, and once you have identified a type of component in the system at hand that you're trying to investigate, and where you're trying to explain a mechanism, you have a constraint that you can like rely on this previous knowledge, right? So it does also do the constraining work in your system, but not only in the sense that it restricts all the other possibilities, but also in the sense like, oh, now I also know something positive about what that system can do, namely, for instance, in this example, to have these mutually incompatible expression patterns. So.
Okay, thank you. Yeah, I mean, I think I need to think about that a bit more, but that's really useful. Thank you.